You will get the length, norm, or magnitude of a vector in calculus. Now we are expanding the idea to linear algebra. Suppose you have a vector in Euclidean space of dimension n. The norm or length or magnitude of the vector is defined as square root of the very first component to the second power plus the second component to the second power plus the last component to the second power. You saw these examples in calculus, elementary calculus as well. Let V be a vector with components 0, -2, 1, 4, and -2. Then the length or magnitude is equal to square root of 0 squared plus 4 plus 1 squared plus 16 plus 4, which is basically square root of 25 or 5 units. And note for you, each vector in the standard basis of the Euclidean space of dimension n has length 1. It is called a standard unit vector in Euclidean space Rn. For example, E1 is equal to 1, 0, 0, 0. The rest of the elements are all 0. So if I ask you to find the magnitude of E1, you're basically saying that I'm adding 1 to a bunch of zeros. This is. So we have an example of a standard unit vector in Euclidean space Rn. Just a quick note for you. Suppose V is a vector and C is a scalar, just a number. Then we have the following property. The length or the magnitude or the norm of CV is nothing but the absolute value of C times the magnitude of V. And make sure you're using the absolute value for C as well. So why is that? Let's take a look at the sketch of the proof. If V is defined as V1, V2, Vn, CV is basically CV1, CV2, CVn, all right? So if I ask you to find the norm or magnitude of CV, you're basically saying that, hey, I have the square root of each of these elements to the second power. C squared, V1 squared, C squared, V2 squared, and so on. C squared, Vn squared. So basically you can factor out C squared. Square root of C squared, V1 squared, V2 squared, and Vn squared, which is basically the square root of C squared, which we always use the absolute value here, times the square root of V1 squared, V2 squared plus Vn squared, which is nothing but absolute value of C times the magnitude of vector